Input UK, and then you can say Martin Kevin.
Okay. Can you see my screen?
Nope.
Yeah.
The one with the presentation.
Yes.
Yeah.
Which are you? Team NB or Team WS?
NB, but I'm streaming with WS. I'm sharing the screen from this computer.
I cannot see actually the screen. Now yes.
I do.
I think
now,
you just have to click on my name.
Yeah, you have to go to Team WS.
Okay. Ruben, Salvo.
Which is by clicking on the icon with the two people underneath your avatar, you will see all the members, and then click on Team WS.
Oh. Okay. I don't know if everybody's here. Oh yeah, a list of names would be really helpful. Okay.
Hey guys, Tom here.
Hi, Tom.
Hi, Tom.
Hi, Tom.
Hi, Tom.
Okay, then I think we have almost everybody here, from what I heard. Yeah, it's nice
Yeah, I
that you
don't
could
know if
arrange
this
something like that.
so we should probably just get started.
Sorry? I didn't understand that.
I said I don't know if Francisco is going to join, so we should probably just get started.
Yeah, Francisco's missing. That is true. Yeah, I hope he joins maybe in a couple of minutes.
We have one that connected just now, so maybe Zoom.
Okay. Yeah, like you saw, I prepared some slides, but these slides are just yeah, they repeat just the topics that we had on the list, and I added some sentences to some of the points. So some of this is just my personal opinion, so it doesn't reflect maybe the opinion of all of us. Yeah, it's just to clear up that point. So let's see.
So you added some comments at yourself.
Yeah, and there are some comments in between. This is also just personal opinion, so
yeah,
don't take everything for granted. And the order of these points here, it's also I just thought about what is the most important stuff. Yeah, so we may not cover all of this, but I hope that we can at least cover the most important points today, and I will make sure that we end at the scheduled time. Yeah. So the first important point that is always recurring is the output structure, and everybody who had a look in the output structure probably knows why. So currently the problem is that the output structure is not divided into separate classes, like we have for the driver, for the solvers, and for everything else. And this is really a big issue because it's just a big chunk of code, especially for example, for the history files that you have to modify to add just a simple additional output. So a couple of months, or maybe even a year ago, we already had a discussion on that. I cannot remember exactly what we discussed, but these are the main ideas that we had. So we want to let the individual solvers define the specific output, and then you have output classes that are structured similar to the driver that just collect all of these outputs, and they write it then, and the base output class then writes it to a file, yeah, or to the history file, or some other file, other files that you need. Yeah, so this is the main idea in this regard. But the big problem is where to start the implementation and who starts the implementation. Huh? So I think these are the big points that really delayed this restructuring. Yeah, Tom, if you want to add a couple of words.
I can jump in here because I remember our discussions a while ago, and I can update people on the progress, although things have stalled a little bit. So first of all, I think I'm getting a little bit of feedback. There's a little bit of buzz. Is anybody else hearing that? I'd say if you're not speaking, maybe just mute.
Yeah, there is some background noise.
Yeah, maybe just mute if you're not speaking, since we have so many folks. All right, thanks. It went away. So, okay, my comment was going to be that way back when we had this discussion, splitting things into, we have our typical model where we have the structure class, and then we have physics classes that take care of the individual solvers. And I think that's a good approach. And so about a year ago, you all remember we started rewriting the output to do all the parallel I/O on the back end. And so all the restarts are now written in parallel, binary, etc. All that's working great. And when we put that in, you may have noticed one of the things that happened is we have these load local data routines where you can now customize the data that goes into the files. And this is an output structure. And so if I remember our conversation correctly, the idea was always that we would then, as a next step, take the output structure class, which will contain all the base routines, but we will essentially create new output underscore physics classes that will take, first of all, their load local underscore whatever class where you actually load up the data. So for instance, there's one for load local data underscore flow. So this would be for, I guess, output direct mean or something like that. We can talk about names later, but the idea would be to put that class inside of, or put that routine inside of that class, so that we're doing the correct data encapsulation where we keep routines that are general in the parent class, and then we have stuff that relies on the actual solver you're using inside of an output class for the particular solver. That's how I remember it. Guys, feel free to chime in. I think everything's set up to keep working in that direction. It's been stalled now for some months after we finish the parallel I/O stuff.
Yeah.
Yeah, maybe if I can say, I added a few comments in the presentation here and there. So I agree with what Tom's saying. I think a good idea will be maybe to do it kind of like the transfer was done. So to abstract that information treatment with respect to the output physical stuff. I don't know if you guys know what I mean.
Yeah, I think it's the same idea, Ruben.
Yeah.
I think that's correct.
Yeah, and we already started a little bit with that, with the solver machinery stuff. So at least there's a separate file where some of the solver machinery stuff is done. And
yeah, could you guys give an update? Maybe Salvo, if you're there, or
yeah, I'm here.
What's the latest on the output? Because I recall that we were going to move a bunch of stuff from solver direct mean into output underscore.
Exactly. So we were thinking to move there to the output class. Everything was computation of some quantities. They are not related to the directly related to solving the Navier-Stokes, so the Rand's equation. For example, the Euler solver doesn't need to, though the adjoint does. That was actually a question mark, and we have to discuss about it. Doesn't need to solve to calculate the lift coefficient to be solved. So what I did in my case, starting from the conversation that we had last year, I moved all the computation of performance parameters in these output files, which is called output physics. And there, and I put my stuff there as I invite for the other people to move also their performance parameter there, because I guess we should find first an intermediate step. I remember we talked about this. Everybody has to kind of create methods for his own stuff and remove all the printing and writing and computation for these very big general routines, in which then you are forced to have many ifs. And then I think when we have cleared this structure in some modules, then we can actually think about it, a better structure using the class and this abstract approach.
Mm-hmm.
That was actually what I did in my case. I removed actually in few routines, all the things strictly related to turbo machinery. So, for example, when I write the history at the on the screen, I just in that big file that write the history on the terminal. Well, the convergence history. I just put the things I want to print in a different routine, so that then at least there is still an if, but then there is only a method and not like 2,000 lines of codes.
Yeah, and this is goes also along with the idea that you had, Tom, with the local data routines, right? So we first break everything we have up in routines, and then we move it into the solver.
Yeah. I was just actually right now looking over in the solver, and I see that I was looking at the turbo performance one that you put into the file output physics. So yeah, I mean, have you? I don't know, in your current branch, have you gone ahead and created a new any new output classes, or have you just moved things into this new file and it's still under C output?
No, it's still under C output. So there is no yet any, let's say, sub layer or top layer of class and then a small class. I was actually waiting for a feedback before actually move on, or for a general discussion like the one we are having now.
Yeah, I think it's still in line with what we wanted to do, and to maybe give a little more detail since we're getting into the specifics here. I think in the output structure class, so in the parent class, I was expecting that we either make the data public or we give some simple methods such that the solver classes can sort of reach in and fill up the data arrays like you're already seeing happen, but also the residual histories, force coefficients, things on surfaces, all that kind of stuff that goes in the history file too. So yeah, I think it's the right direction.
Yeah, and we should probably start with that soon, I would say.
So then the tough question, who's the guinea pig?
Yeah, we need someone who takes the lead on this topic. I know probably all of us are quite busy with stuff. But I mean, it doesn't mean that you have to do everything on your own. Yeah, it's just to maybe collect this information also from the other people.
Yeah, in fact, because of course you cannot start messing around, because we know there are a bunch of conflicts that you can have on this file, on the output structure. That's actually the major concern. So I think it has to be very programmed and very well designed, the transition. Well, yeah. I can actually in the spare time start to have a look at it and see if I can figure out first of all a way of approaching the problem. Perhaps by splitting, at least by splitting this huge file in a smaller file and see if I can find a pattern there.
Yeah. I think that would be great if you have the time. The other strategy I'll share, this is something general for everybody, I guess. The thing I always try to do is build up new classes and new data structures that are independent of what's already in the code. Build them up right alongside inside the solver without changing the original implementation, so that you can at one point, just with maybe one change of line of code that calls a different output class, you can essentially switch to the new implementation without creating any conflict. So this is what I did with the partitioning and the parallel IO. Basically just, you could in your file output physics, you could create a new class that's not being used yet. You can, create these new routines that will load the data, that will load the...
Sorry? I didn't understand that.
I said I don't know if Francisco's going to join, so we should probably just get started.
Yeah, Francisco's missing. That is true. Yeah, I hope he joins.
History that will load, etc. And basically build up the entire thing, and then, over in output structure or in the solver, just, or in the driver, just switch one line to call your new routines. And so you can test. and then you don't have to worry about the conflicts. So that's something I always do.
That's a good one.
Yeah, and the turbo machinery stuff is a good example, I think, for creating this stuff, right? Because you have a lot of output, a lot of specific output. So,
yeah, and then I just put it on different method apart. But
yeah, we just need someone who creates this structure, right? So this base structure, and
everybody else can move their solvers over. Basically, if you could create one example for the turbo machinery that's working, even if it's not active yet, you can do a pull request, show everybody what you've got, and folks can just take their own work, their own solvers, and start creating those similar classes and routines.
I can give you a hand, Sandro, with that if you want. I've been doing adding some stuff into the output lately because I want to improve it for like a couple of joint, etc. So I've been looking into the output structure recently, so I have it pretty fresh. So I can also give you a hand. We can just organize a telecom between us.
Yeah, exactly. And actually, the first one of my major concern is also that when we actually need a quantity on the output structure, we have the solver container, and most likely what we do is like that we have an ad hoc method for it. So this we also have to figure out how many. I can make an example. For example, I need to call from the solver like a certain quantity, which can be like an average values somewhere. And I add a customized call. So maybe for certain solvers, certain calls, they should be customized so that then we have fixed amount of routines, also solver level. And then for specific stuff, we should kind of find a trade-off, I guess. I don't know if I made myself clear for this.
I missed that point a little bit. Do you have another example?
So, for example, I don't know. I guess when you want to for the residuals, we have a common container in which depends on the dimension of the problem or of other stuff. We can call the residual vector, and it's called get residual, and that's it. But if you have specific quantities, like for example, in my case, is density in, density out, which is a sum average that I do in the inflow outflow boundaries. Then I have solver get density in. So it's a customized function that I use. So we also have to figure out the way of encapsulate this kind of data more in a general way.
Yeah, okay. I think I see what you mean. So, but if you have a specific output class for just the flow, or even more specific for turbo machinery, you always know that the solver coming in will be the one that has the get density in or out, correct?
Yeah, exactly. Yeah, that can be a solution indeed.
Yeah.
Also,
comments, guys? Yeah, go ahead.
Also, something that we could consider is also having like multi-zone stuff, because, for example, in my case that I'm iterating over different zones, I struggle to output because I need to output the convergence, and that's what I put with the last point in that comment there. I have to output the residual of fluid iteration. I have to output the residual of structure iteration. Then I have a residual of the couple iteration. Then I have like all shit. So that's we should probably need to think about it in like multi-zone terms.
Yeah, that's also something that I actually add on my pull request in July, so that the history file is printed for all the zones, but the video print is only the zone 0. So we should find also a way of improve that, because if you go now on the output structure where we go when we print the residuals at screen, you will see like that there is val zone equal to 0. Otherwise, basically, you will print all the residual out for each zone, and then you cannot really actually see what is the trend by looking at the numbers. So what we and Tim were thinking is to have maybe only the zone 0 printed, but maybe every thought iteration to print like a summary also for the other zones. Or
I print them all because I run them sequentially. So I print fluid, and then I print the structure, and then I print coupled.
Okay, but if, for example, you have 2 zone and 2 structure, I'm just making an example. Then you,
It depends on whether you run them sequentially or do you run them simultaneously. So,
yeah, they are run simultaneously, but in general, I think if, for example, you start them in like 4 or 5 iteration 0 and then 4 or 5 iteration 1, I think it becomes very difficult to follow what is going on. But I think we should actually understand what is the best strategy also there. Any suggestion for?
Yeah, I would say that if you run multi-fluid zones, now you see just the residual for the zone 0, and then you miss a lot of information about what's going on the other part of the domain. So it is true that if you have like 5, 6 zones, you don't get the trend, but it's also true that if you only look at the residual from one single zone, maybe there's something really bad going on in another zone, and you just don't recognize it.
What if you just sum everything up from all the zones?
Exactly, that can be an option.
Yeah, for something like the time spectral or harmonic balance, it's very critical actually to know if you're converged. You want to sum them all up. I mean, the same thing for if you have mixing plane or any other.
Yeah, exactly. If you have a relative motion, then you should have information from all the zones.
Yeah, this is one of those things where we always wanted to do that, but the way the output is so mangled, it's a nightmare to add it. So yeah, this would be great. I mean, I think the loops are there over the zones. We just need to do some summations, and it should be fine.
Yeah, indeed.
I think at the end of the day, the structure should be similar to what we did with the driver and the iteration.
Yeah, there's another thing though with the multiple zones there related. The partitioning now also happens on the per zone level. So if you have very many zones, that is not very efficient either.
Yeah, that's something I also wanted to say. Like, for example, in my case, it's not really efficient that I partition for like fluid and structure zones with the same number of processors. So that's something that I also want to do.
But even if you have only fluid zones,
even if you
then it makes sense to have a number.
Yeah, you probably have all noticed that there is no consistent way of defining a multi-zone problem. A lot of the config options at the moment are just duplicated, right? To
where to read information from. I mean, there are things that you wouldn't need to redefine.
Okay, so then from what I'm understanding, then it would be smart to have different config files for more than for zone for physics. Is that correct?
Thanks, yeah. Kind of. Yeah, I understand. I also agree. More than
because
physics.
Instead of talking by zone, we could talk about physics, so multi-physics, so each physics has its own config file, and then for each zone we use the super config file. This would be my idea.
Yeah, but that's the other question. Like originally, we had the distributed zones as physics, so I think we might need to define whether we need to add another layer there.
Yeah, but it's not always that zone corresponds to a physics, like the example I told you before.
Yeah, no, I understand.
And actually, this is also open to what the problem that Edwin pointed out some months ago, that we do the loop over the zone like we do the loop over the physics. So yeah, maybe this actually, maybe the nature, this also demonstrates that the nature of the problem is different. So maybe the answer to this is to have another layer for physics on top of the layer for zone. But I'm just saying, it's food for thoughts. I don't know.
I mean, when we said the zones, the idea of zones was physics, so one zone per physics. So.
Yeah, but now we have multi-zone with same physics, also.
Yeah,
and you
I understand that.
Yeah, I think it's we should find also, maybe the answer is to find a good diversification between what actually multi-zone means on the same physics and what multi-zone means on different physics. Yeah. But I don't know.
No, I think
But I don't see a problem here with the conflict cards. I mean, if you don't provide the conflict file for a zone, then you just use one from this.
No, indeed. Sorry, I was actually saying that this problem can be, the nature of this problem is related to the fact that we should be able to distinguish also a conflict file level when a multi-zone, because we saw two clear examples in which one conflict file is fine and when one conflict file is not fine. So when you have two physics, maybe it's more clever to have it's better to have two different conflict files. Instead, when you have like multi-zone with the same physics, one conflict file is enough.
But one thing I'm missing from the multi-zone with same physics, are you defining like different, because in that sense I haven't really run anything myself, but are you defining different meshes for different zone?
It's one mesh. Yeah, I mean it's different mesh. Yeah, and then you have over the single all in one single file. And then you have the eyes-on iterator, or let's say pointer, on top of each mesh.
But yes, you have multiple mesh. Well, we can talk about this later, but you have multiple meshes, and yes, that's
one basically pasted one after each other, pasted one after each other.
Yeah, maybe I can clear up just so everybody's on the same page what happened kind of historically. So the code didn't have zones for a few years. A couple years at least. And so the original idea was to put in zones, but they were, in the beginning, they were meant to be different physical regions in the domain that each have their own mesh. So they're separate physical regions. That was the original intent. So we started using the zones because we wanted to do sliding meshes and things like that, more like harmonic balance. Then we started using it also for the FSI stuff. So we started using the same index, the first one, the highest one for zone, for both physical regions in the domain that each have their own grid for the same physics, but also for the same physical regions in the domain that have multiple physics.
Exactly.
So that's the conflict that everybody's talking about.
No, I have different meshes for each. Like I have a mesh for the fluid and a mesh for the structure. They are different.
That could be as well. Yeah, it's the same thing. But I'm just trying to highlight the differences between, you could have basically all of the physics and all of the physical regions go into that zone, and there's a little bit of a conflict. But
yeah, I understand. Yeah, that I agree.
Yeah. So what is your solution? What do you have to suggestion to that, Tom?
Well, I just have two comments on the config stuff because. I really would like to have a good solution for this. This is very important. The two things I would say are, one, keep in mind that the config file is already the hardest thing for new users to learn and the biggest barrier to entry to code by far. I mean, this is something we get questions about every day. Options change. It's a nightmare for new people to use the code. So just keep that in mind. I mean, anything we do should really be simple. It should be backward compatible, and in some ways maybe could even improve it. We could always improve it. The second thing is I guess that's tied to the first one. I just having multiple configs or having super sub, as long as it's backward compatible, I'm okay with it. But yeah, I guess just it's hard to use, and we need to keep it simple. Really things.
Okay. So you will suggest to stay with one config then? Most, I mean, not that, but that's kind of the bottom line.
Well, I mean, as long as, I think in terms of backward compatibility, so, if all of a sudden we have multiple config files for, I guess not that many people are using multi-zone yet, so that's an advantage. We can still kind of do things differently for multi-zone, but I think making it harder for people to define options would be very confusing for people. So I'm just interested in the cleanest solution and the simplest.
I am pretty strong advocating for having it differently, and I added the point of why there. I think it's easier if we are talking about making it easier. I think it's easier for somebody that like if we're doing like talking about specifically multiphysics. It's easier for a person who knows about fluids to just set a config file in which you don't have a lot of other physics options, and vice versa. So talking about multiphysics, I think is definitely much easier if you have different config files to understand. Because, for example, if you say, okay, linear solver iterations for the fluid solver is very obvious. Oh, it's 2, 3, 4 iterations, that's enough. Then you go into any other problem, and 2, 3, 4 iterations don't even get any close to convergence of the linear system. So there are options that are repeated there, but that have a completely different meaning between one physics and another.
This is Francisco. I have a question. So, hi, how are you? So, as you said before, we define the sound just thinking on geometrical sounds for spline interfaces, or that kind of stuff, or even if you generate a grid with Eisen, you will have different. It is possible to have different sounds in a CGNS file, and just because of you have pyramids in one, text in the other, or so geometrical sounds. It would be very complicated to add a new index for the physics, because if we think that in the future you two can deal with really complicated problem, maybe we are going to have sliding surfaces and multiphysics and everything together. So it's for me it's a little difficult to see how we are going to combine the concept of different sounds from the geometrical point of view with the concept of multiphysics. So maybe we just need to add a new index. At the highest level index is going to be just the physics that you are solving, independently if you have songs. So maybe that's something that we can think about and be very careful with the names, because it's complicated to identify the problem that way. And it makes sense. It's possible to add a new index and say that it is physics, and it's going to be the highest level for all the data structures that we have.
Yeah, I think that's the best solution, actually. I think the best solution is to split between multi-zone in the sense that it's taken for harmonic balance, etc., and multi-zone in the sense of taking it for different physics. I think that's it's a clear difference.
I think so. I think
so. Yes, actually,
it's a big change, but it will solve the problems and will allow the code to grow. If not, we are going to be stuck as we start dealing with really complicated problems.
And I actually think that that's precisely where the difference in the point of view of the config file comes in. So it's pretty much the same difference. If you have different physics, then it makes a lot of sense to have different config files, whether if you have the same physics but different geometrical parts, whatever, you don't want to have
it's the same with the output, right? I mean, there you have the same problem. And I think this would also solve some of the difficulties we might encounter there.
Yes.
If you have a clear distinction between these two things.
Yeah. Actually, it will be easier also to have, to be able to read different meshes for different physics.
But then that would be a different config file for each physics, and then
it will have to be like a master or like a super config file in which define how each different physics interact with each other, because of course you need to provide that to the code.
Yes. So then for each physics would be handled different, and then we can maybe allow a list of different options for each zone. When I mean zone here, I mean then spatial zone, geometrical zone, or time zone in case of harmonic balance.
Yes.
Yeah, that would be physics probably.
I think we need to think on that. Yeah.
Yeah, indeed. I mean, I think it's quite a big problem too. And yeah, even in this way, we are communicating. We should maybe have some example what are the most complicated problem we can have it, and then try to figure out if we find a general way of approaching all of them.
That's a very good idea. Why don't we find a volunteer to think on the most complicated problem that, well, I can't think on that, but we think in a very complicated problem, multi-fixed problem with multi-zones, and we say, okay, let's try to create a structure that will solve that in an elegant way, so something easy to understand. Because even the multiple conflict file is something that we need to tackle in the future. Just thinking on multi-point optimizations now are very complicated to do because it's difficult to express different solutions in the same conflict file. So we need to, I think it will be useful to put also the multi-point optimization, how we are going to express that in one single conflict file if you want to run a program at takeoff, landing, cruise, and optimize everything together. You need different conflict files to deal with that.
I can do that. I can
okay.
put together an example for that.
I think that would be great if we put together an example,
Yeah,
a very complicated example.
I don't know if you saw it already. GitHub has a new feature, so it's like a discussion board, right? This is a good place to discuss something like that, right? Maybe also other people propose some difficult problems. So it's only accessible by the developers, of course. So you might want to use that feature for that.
Yeah, that's a good idea. I like that new board. It's about time.
It's a little bit hidden, but yeah, I think it's useful.
Yeah, you go to teams and then click on developers side of developers. Yeah, that just showed up maybe a month ago.
It's just a week ago, I think, or 2 weeks ago.
Yeah, I think it's a great idea. It's a great idea. So.
Yeah, but this is a good way to start, I think. Yeah.
Okay, I think we can move to another topic.
Okay. Well, the next one. Maybe Tom has a few words on that.
Hey, everybody's favorite topic.
You repeat yourself, but it's okay.
Everybody's favorite topic. Okay, so the first part is complete. So let me back up. If anybody's ever looked at the constructor of C physical geometry, you know why this is horrible. So if you haven't looked at it, don't do that to yourself. So the first part of this is, so really the root problem is the periodic BC is not working well. Okay, everybody knows that. The problem is it's nearly impossible to fix it given the state of the current C physical geometry constructor. It's just a mess. So as a precursor to fixing the periodic boundary condition, we have to fix the kind of, it's just mangled all the stuff that does the partitioning and the communication schedules, all that stuff. So the first part of this is completed. It's in the branch called fixed partitioning. You probably saw I commented on one of the issues that was posted. That branch is there. It's up to date with develop. It is a complete rewrite of the physical geometry constructor, and it breaks it down into subroutines, and it does everything nicely, non-blocking, whatever. Everything's clean. So if you want, you can go take a look at that. It's there. That can be pushed very soon. So I think that's more or less ready. But the thing is, that was step one. Basically, just to rewrite all that part so that as a second step, we can go in and properly do the periodic boundary condition and the partitioning of that. So I'm going to add new routines that do all of that correctly, but that part's not there yet. So basically, the thing that's in the branch now is just is essentially a rewrite that gives you nearly the exact same result as the original. It's better, it's more scalable as far as I can tell. I've done a lot of bug checking, but when I push that or do a pull request, I would appreciate feedback on that. And so the idea is, when that's complete, we can go ahead and add routines that will do the periodic BCs on the fly. So basically, when you read in the mesh, no longer calling an outside executable to create the halos and then write a new mesh and then read that mesh. The idea would just be to do it all on the fly and do the partitioning right there, which will now be a lot easier. So the only other comment I have on this is that I've actually been given time at work to work on this over the next year. So this is coming. We will need it. So just so you guys know that that's all in process. And I'm open to any feedback or any comments you guys have. I know it's been a long time. People want this to work. It's a bit complicated, but it's getting there. So that's the update.
Tom, you know that I've done it for the DG solver. It's a little easier for the finite element solver, but the idea can be pretty much the same. So if you need, I can help you out with that.
Yeah, that'd be great. And actually, Evan, I was going to ask if we've talked about this a couple times. Do you have any old code where you've done it for vertex space, or no?
No.
Yeah. See,
the problem is that there are additional. You need all the elements there, and that's the tricky part. I exactly know how to do it, but it is tedious to do.
Yeah, that's what. So just to give a little more history, we had several implementations of this over the years, and what we had done at first was create halo layers on both sides of the periodic boundary. Just the redundancy made it easier, but then we took one away. The idea is, I mean, you all probably know the issue. The vertices are on the boundary, so you have to complete the control volumes, and you have a few options to do that. You could have halos on both sides. You could have one halo on one side that completes it. You could also do what I've seen in literature, where you just you don't duplicate anything. You just communicate more data. You basically send residuals across back and forth.
I do that for the finite element solver. And the reason is for that, well, that's the long story. That's the time accurate local time stepping, but I don't think that's going to be an issue for the finite element solver.
Yeah. So, I mean, it's one of these things that if you did it in serial, you could write this in a day. The problem is all this other stuff that goes along with it. But yeah, Edwin, I would really appreciate that. I'll probably, I've looked through your stuff for the DG solver for that exact purpose. But yeah, maybe some of the stuff that, we have the old routines that do the matching and the checking. So I can pull a lot of that out of our old, well, we've changed the name a few times now. I don't know. It used to be PVC and then it was MSH. I guess it's MSH now.
No, it's MSH. Yeah, it's MSH.
Yeah, so I mean, we have a lot of the stuff that does the matching and all that. Anyway, this is it's coming. Like Edwin said, we know how to do it in theory. That's not the problem. It's all the practical implications of doing this in parallel and scalable and all that stuff. But it's coming, and like I said, I have time built into my schedule this coming year, starting as soon as really, I guess, January. I could probably start on it now, but there's other stuff going on, so. It's coming. Any comments on that though, guys? One more thing. When I do push this stuff for all the partitioning, I would really appreciate you guys testing on problems. It's a big change. It changes the residuals. I mean, unfortunately, the test cases, anything that runs multi-grid, the agglomeration gives slightly different results because the partitioning is just slightly different. So basically, all the residuals for parallel cases change. So we really need to test.
Yeah. Not only multi-grid, right? Also, if you do a non-explicit smoother, also changes when you do the partitioning.
Yeah, all the partitioning classes, the subroutines that I rewrote, it's so similar that actually in a lot of cases it gives almost the exact same partitioning. Not always, but it's slightly different depending on the element types and the ordering of how the element types get partitioned, but it's really close. So some of the cases give exactly the same results, oddly enough, but lucky enough. I don't know whether it's luck or I don't know. But yeah, it's complicated. So we definitely need to test. But I can say that locally on our cluster at Bosch, I've got 4,000 something cores. The finite volume solver is partitioning fine up to the full machine now, whereas before, there were a couple of bottlenecks that were causing problems. So it's definitely an improvement, but we'll need to test it pretty closely. So yeah, I don't want to dominate the conversation here, guys. So anything else on this? Any partitioning or periodic BC stuff? Comments?
I think that's what we wanted to hear.
Yeah, exactly. I have a question actually, Tom, for you. But I usually run with periodic, and I usually have the problem that after there is like the initiator of the multigrid. Well, not of the multigrid because you cannot run the multigrid, but when it's initiating the solver is initiating the Euler solver of the asset, all the runs, all the turbulent solver, then basically the simulation stall. It doesn't start, it ends. And then after that I have to run with different number of processors until I found the correct number that works. Do you think that this partitioning already will fix that, or this will be still related to the periodic?
That's still related. So to give you more specifics on what I did, just like the strategy I told you I use, Salvo, where I write up new routines alongside all the old stuff so I don't change anything. I literally rewrote the C physical geometry constructor, and I overloaded it. So I can change one line of code to turn on the new partitioning and to turn off the new partitioning.
Okay.
And what I do, actually, I cheat because I couldn't all-in-one pull request do the periodic BC yet. You'll see in that branch, I do a conditional statement to check if there's a periodic BC. If there's a periodic BC, I use the old.
Okay. So
for now.
And instead, the idea of Edwin to use to send across the residual, so that you don't need to duplicate the mesh. Is it?
Yeah,
that doesn't solve the problem because you will still need the full elements surrounding a point. That doesn't solve the issue.
Oh, okay. I thought that by sending the
alternative, but yeah, you still need to. So then you have to decide which of the edges on the boundary do you keep them? Do you do like redundant compute? You got to keep then flow variables, gradients, anything like limiters, whatever. You have to transfer those. Then you also have to transfer the residuals from the other edges. So it's, but in the end, the geometry is still the geometry. So yeah, you have to complete the control volumes. This reminds me of one thing I'll just say to inspire conversation. A few of us have talked, I think, in the past about trying to reuse the transfer structure stuff.
Like interpolating, right? You want to interpolating from one side to the other.
And I mean, you run into similar problems. It sounds really good at first, and then when you draw a little picture and you start to think about transferring stuff and what you're going to transfer and how you do it to make sure it's consistent and you're actually imposing the BC correctly, you run into similar issues. So, yeah, I think we're going to go with one of the original approaches, either duplicating the control volumes and then just doing. I mean, either way, it's going to rely on some MPI transfers. I mean, that is unavoidable. But yeah.
That's good and bad at the same time, right? I mean, for example, for the mesh movement, it just works out of the box because you have this periodic structure there with similar to the NDI communication. So I think this is nice.
Yeah. I see. So then, then we'll wait from you to see what will be the possible solution. And as soon as you push and you have stuff to test, I have a bunch of test cases in which I can test it.
Yeah, so I've been tracking the Travis cases very closely, and like I said, a lot of the residuals change a little bit, but I've also run a case like the CRM, so something in the 20 to 50 million cell range, on 4,000 cores or whatever, and it converges to the same answer. So I'm pretty confident everything's okay, but we need to test. So, any other comments on this?
I just want to add something. I don't know if it's actually pertinent with what you are saying. So, when we actually do a restart with the periodic problem, with the periodic boundary condition, there is always a mismatch depending on the number of cores. Is this related with what you are saying, Tom?
Yeah, that's the second half. So fixing all this periodic BC stuff
So maybe I can add something here. So if I remember correctly, if I can recall correctly, we discussed this with Tim. When you restart with periodic and parallel, the order in which you do the communication So imagine that we run 100 iteration and then we restart one, and instead, without restarting, we do 101 iteration. If you run serial with periodic, the residual are exactly the same. However, if you run parallel, the 101 iteration done with one restart and the 101 iteration done without restart are not the same. They don't give the same residual. They are close. And then if you plot the two, if you open the two solutions and you do a difference, you find some red spot in the mesh somewhere, which me and Tim, I think we ended up seeing that this was related to a kind of communication that between the halo of the mesh that intersect the periodic boundary, and it's generating this mismatch in the residuals.
Yes.
The point is that sometimes this can affect a lot the joint.
Exactly.
The discrete joint.
This is the problem actually. So when you, for the restart of the joints, then you have some mismatch and it's really core dependent. And this is a big issue, I would say.
Yeah. So you guys have picked up on it. It's exactly the issue that you think that you said is where a partition boundary for MPI, just for the domain, crosses with periodic BC. That's also, so the part of the issue is we're using an identical communication pattern. Like we're using the exact same routines for both MPI and periodic send receives. And so the order is actually important, and we don't differentiate right now between a periodic send receive and an MPI send receive. So maybe just by chance, the way you partition the number of cores, those intersections between partition boundaries and periodic boundaries move around. The number of them changes, and when that happens, if you haven't ordered the communications to do, say, all of the periodic sends first and then all of the MPI sends first or the second, then you could get this thing where maybe some of the halo nodes at those intersections are not well updated.
Yeah, that's what happened exactly.
Yeah, so we can. I've been thinking about this a bit for rewriting the periodic part, and I know one strategy is just to separate those two lists. Essentially, do all the periodic first, and then all the MPI stuff second. Yeah, I'm thinking about that a little bit. I'm aware that that's a problem.
Actually, just a small comment on this. That's why after the restart, usually there are two set MPI called one after each other. I don't know if you have noticed somewhere the load restart at the end, you have always two set MPI solution.
Yeah.
Because of this problem. Yeah. Well, I mean, if you remove that, one of that, the restart will be always wrong. At least with two, the kind of fix is not perfect, but it's still like physically sound. We don't know what actually is the influence on the AD, but on the discrete joint, but still it seems to work.
Yeah, but
I can imagine where there are a lot of processors that have this situation that can, in effect, make not accurate the discrete joint. But hopefully it will be solved with this new implementation.
Yeah, the point's well taken. It's definitely an issue. It reminds me of another thing that I'll bring up that's a problem. If anybody here has ever tried to run with periodic boundaries that touch each other, that are adjacent, then you've probably realized the code doesn't work. So this is critical, though, because, I mean, things like triply periodic boxes, people use this for testing numerical schemes. This is stuff we just need to have. So that doesn't work right now. So I'm aware of that as well. I'm going to make sure the solution takes care of that, takes that into account.
I think maybe we can... I have just a small comment before actually we go ahead with another topic, is that at the moment also the SU2 mesh, most of the time, sometimes doesn't work. And for the moment I had a Fortran code that does the periodic, I would say, generate actually this halo node structure externally quite well. It's on the mesh tools, just for the people that doesn't know it.
Thanks for putting that up. That's very helpful. I think some people in the community are already using that, so that's great. Yeah, last comment with that also. The intent is that the periodic BC, as it says on the slide here, should be done on the fly. So
no. In fact, I mean, until we don't have that implementation from you for the folks in our just to say that.
Definitely, that's appreciated. Yeah, hoping that this will all be invisible to the user as it should be. So in the future. Okay, yeah. So I guess, long story short, I'll take this one. I'll keep working on it, guys. So I've got this one.
Thanks.
Yeah, thank you.
It's slow, but we're getting there.
We are looking forward to this.
Definitely, yeah. But you don't want to put too much pressure.
No, indeed.
No, indeed.
Well, I think between the config file, the periodic PC, partitioning problems, I mean, these are things we get emails about probably every week, right? So we got to fix these things. This is critical.
Yep. Okay. So I think we can move on if there are no further comments. So the next one is the mesh deformation. Yeah, so the current mesh deformation is not that optimal, yeah, because like it's written here, the boundary conditions, they destroy the symmetry of the matrix. Yeah, so it's not very efficient to use GMRES or DCG step to solve the system. But thanks to Ruben, there's a solution. Yeah, Ruben, if you want to comment on that.
Yeah, I reused my the finite element solver that we put together for the structures, and I adapted it to the mesh deformation, so it's working better. Still can be improved because we definitely need to incorporate a lot of boundary conditions on that, and that's another thing that we will need to look into. But yeah, because now we can use the conjugate gradient. I have maintained the symmetry of the matrix, and the mesh deforms faster. Still, and this will link to another point that I added into the discussion today, that there will be better ways to solve the problem, like better ways to solve the linear system itself. So that will be a next step to solve like problems that are pretty big. Or another idea they had is like we could potentially treat the mesh deformation itself as a solver. So that way, if anyone wants to just collaborate and say, oh, I'll just put radial basis functions to deform meshes or other methods that are out there, that could be a good alternative. I don't know what you guys think.
So by saying that, you mean to make it a bit more easy to extend?
Yeah, to make it a bit more easy to, like, basically what I did is I defined the problem as a linear elastic problem, as a normal one, and then I implemented like boundary conditions, imposed deformations, which is basically what you get when you come from the structural solver, and like some other boundary conditions. But the thing is, it will be interesting to have that opaque. Like you receive some displacements in a certain set of boundaries. You have another set of boundaries that you say, okay, these boundaries have to be fixed, or they can move in a certain axis, for example, if they are symmetric. And then the way the mesh is deformed, that could be a solver in itself.
I agree.
And that could be a way to make this more efficient, because at the end it depends a lot on the domain that you have. For example, moving this as a linear problem, if you have like a very narrow channel, for example, and you have something inside the channel that moves, as the borders of the channel will be fixed, then the mesh breaks pretty soon. And that goes on, like different topologies, they bring you problems with the mesh. So of course there are different methods to solve different problems.
Yeah, no, indeed.
It will be interesting to treat this as a solver itself.
Yeah. Actually, me and Tim, we are facing the same problem with deforming the turbo machinery domain, because it's like a section of a channel, as you said, and you want to maintain the external part, or the surface of the channel itself fixed, and then it breaks.
Yeah, for example, it would be good to have it in cylindrical coordinates.
Yeah,
and stuff like that, and additional boundary conditions. This is also something very important point.
Yeah, to be able to define the boundary conditions. How do you want the boundary conditions that are not moving? How do you want them to behave? That will be also interesting. So that's what I mean in my first point, like adding boundary conditions, because it's not yet usable for everyone. Like if you have symmetric boundary conditions, I haven't implemented that for it. Yeah. For my problems, I've tested it and like re-implemented the mesh as I did. Works better, works much better. So it's like a prototype. As
this new one is now in the code, yeah. So if anyone wants to test it, yeah.
Yeah, it's there. So that's pretty much what Tom was saying earlier. That I implemented it alongside, so I didn't remove anything that was there. I just implemented it alongside, so anyone can test and play around with the method.
Yeah, Ruben, do you have any idea how? How much better the performance is if you go with, or how the performance compares if you were to use this versus another, the original solver for kind of a standard deformation problem?
Well, I have the idea that of what, like, I have my experience in the problems that I was running. So before I implemented this, as Tim pointed in the first point, the boundary conditions were imposed. Like, okay, we'll remove a row. Then you had no symmetric. No symmetry in the matrix, so you could not use CG conjugate grading, and conjugate grading goes much faster in deforming the mesh when you have the imposed deformation. So that was like the main idea. And the thing is, now you can use, like, you can reuse all the element-based structure, etc.
Yeah, that's now in the branch.
Sorry,
Francisco, you're cutting out a little bit, but he's asking if it's in the develop branch.
Yeah, it's in the like, I just merged it today actually, so it's in the develop branch. If you go to the mesh deformation, there is like I appended like ELES, so like elasticity.
Yeah, and some additional comment. CG uses way less memory than GMRS or BCG set, so the memory also goes down by a lot.
Yeah, that goes in the line of the. I have some further comments in a slide that is later that I added, like linear solvers for stiff systems. So we can go back to this if you guys want, because otherwise we will delay a lot the rest of the discussion. But basically, for this kind of stiff systems, there will be better alternatives for the linear solvers instead of just CG.
I have in CE, we are using preconditioner.
So ever since ILU was fixed, I've been using that in the structural problems only. I haven't really used them for the mesh, but definitely in the structural problems they go faster.
Yeah,
and they are the same
comment. Yeah. My experience with deformation improved a lot once I started using ILU1. 0 in practical application, complicated problem, really doesn't work. But if you switch to 1, it works much better.
Yeah, but
it should be a default for video deformation.
Yeah, the thing is, basically that links to the morphology of the problem. So you have the system AX equals B, and yeah, the way you solve the linear problem is the key there. So that's why I believe you have CE with ALU1, it works better. Another alternative could be to factorize the matrix. So you have factorized this at the beginning, and then it's just a substitution. So you can morph it as many times as you want.
Okay. Yeah, I could see that being an option, like dynamic grid calculations, but anyway. Sorry, Francisco, what were you going to say?
Yeah, from the practical point of view, I found that grid deformation is always a big problem when you optimize things. And it's very difficult to have a method that works always. And it's confusing for the user to decide that one solve distance or how to choose the model of elasticity. When you work on a complicated problem and find some defaults that they work.
I think,
I think the deformation works great with simple grids, but once you go to complicated problems, another story.
Yeah, and I think that links to what I mean with treating it as a solver, because as you go to more complicated problems, it could be interesting to have different solvers to test or to try for each problem which one works better. I know there are a lot of ways to move meshes, and a lot of people do them differently. So if we treated this as a solver, we could encourage people joining and trying to put their own methods to move the mesh into the code, and that could be like a really interesting contribution. Or like it would be nice to have experts on this, because this is already by itself a big problem, and there's a lot of people doing research on this. So.
Yeah, that'd be great. I like that idea. So then, Ruben, is it safe to say you're taking the lead on this one?
Yeah, I can look into that. Yeah,
I would say at first it's probably just the taking what you have already implemented and then seeing how we can make it the standard if it's performing well.
Yeah. I mean, in general, it's pretty much the same. The only difference is that there are so it could be used immediately. The only difference is that I will need, and in this I will need help, because I will need someone else to treat with the boundary conditions, because I don't really know how you guys treat different boundaries from the fluid side. So those were the ones that I left out.
Sure.
Actually, the periodic one, of course, but that's already discussed widely.
Yeah, we can.
Symmetric boundary conditions could be interesting.
We can help with that. They're pretty simple. You've probably seen them. I mean, we basically just impose the deformation and any boundaries that are moving, and then we hold essentially everything else fixed. Symmetry is a little interesting because the points are allowed to move in the plane, but that's about it.
Yeah. So I mean, I think that's pretty much what is missing between the implementation I just did and the standard one, and the previous one.
Okay.
That's
okay.
the difference.
Francisco could probably help give us some realistic input as well, like how the boundaries should move. I'm sure he has cases that are.
Yeah, and also some test cases to try actually.
Perfect.
I think in the past I tried Ruben implementation. It was still worth it, so it reduced the time and the number of iterations. Even using Gmesh, I was using Gmesh, but it worked much better than the previous implementation with this cluster in Nicolai.
Thanks.
Okay. I think we can move on. Probably.
Yep, that's perfect.
Okay, very good. So these were the improvements. So I try to audit a little bit. So we come on to some features that were requested by some people, and yeah. I think it's good to give some opinions on it.
Yeah, sorry to interrupt. I guess we've got about 45 minutes.
Yep.
We should cherry pick a handful of the most critical ones between the set. You just run the code through more complicated stuff. But yeah, I mean, we need, this is a great point. We need tutorials, and I mean, we don't need to write a ton of documentation, but we're pretty lacking there right now. So any help, anybody, everybody.
Yeah. But I think that we need to try to have a video tutorial for those kind of things, small videos, 2 minutes, and explain some. We spoke about this in the past. That's the future.
Before we go there, though, guys, just to come back to this regressions thing, I think we're all on the same page. Tutorials, videos, documentation. I mean, I'm in support of anything people do in that front. So one other thought with the regression test stuff is we could, for instance, try to reduce the compiler optimization, but then we run the threat of missing what happens when we do -03, which is important. We could do maybe just one case that compiles with -03 and just run a few of the regressions just for checking that, and then run the other test cases all at -01 or 2 or something, and that should cut the compile time. But yeah, open to ideas here still. I don't know if folks want to add anything else on getting the times down or other ideas for kind of breaking down the problems.
I just checked on the website, and actually, indeed, there are some plans. Of course, if you pay, so they have unlimited build minutes and unlimited repositories, and it starts from $70 per month. So
I mean, we might have this option in the future. Yeah, but that's all I can say for that.
No, yeah, indeed. No, yes. And also, I would say that, I don't know if it's also a matter of discussion, but we should also test things like SU2 Soul or add something to test this kind of things in the code.
Yeah, same goes for the regressions. I mean, I know we're up against time limits, but that's no excuse. I mean, I think what we're already doing is good, but we should make it mandatory with pull requests that you have new tests that cover your features, because that's the only way to keep everything working in the code. So, and things are missing. I mean, we've had this problem over the years. For a long time, we didn't have any of the deformation stuff covered. We didn't have the Python stuff covered. We've slowly been adding things, but just like documentation, guys, to be a little entrepreneurial, go ahead and add new regressions for things that you find aren't being covered, add new documentation. We have to spread that in all chip in.
Mm-hmm. Yeah. Okay. What's the bottom line here? I mean, we can wait until there is a possibility to have a paid plan. Yeah, before we look around for alternatives, and in the meantime, we try to
reduce the amount.
Stay under the 1 hour limit.
So what was the cost again, Antonio?
So the basic plan starts from $70 per month.
70
per month.
Okay, maybe what I can do is just write them another email and tell them about our problem and see what they say. I mean, it can't hurt just to beg for mercy and say, hey, we're an open source project, and give them the pity thing, and then see if what they can do. And then this is something we can bring up at the developers meeting.
Yep.
Even if the foundation isn't around yet, maybe we can get the faculty to chip in to cover this. I mean, so this is very important. So
yeah,
exactly.
So what do you get for this $70 a month?
So I saw the first bullet is unlimited build time. So that's the first bullet.
Okay.
But there is one concurrent job, unlimited repositories, and unlimited collaborators. So the only difference between each plan is that the amount of concurrent jobs that you can run. That's the only limitation.
But at the moment, we can run parallel jobs, right? With the free version. At least I've seen multiple branch running regression tests.
I think there are only 4 concurrent jobs or something like that. That's what I noticed.
Yeah, but now with the 70s, well, anyway, we'll see it. But
I mean, the overall time, I think, is not very important. How fast the tests complete in the end. Whether it takes 2 hours or 3, okay. How it is, right? I don't know. That's not the highest priority. Put it that way.
I don't know. Maybe also we should have a better look, but maybe they also allow to use more processors if you have a paid account, and that will solve many problems, I would say.
Maybe, yeah. I think $70 is not that much, and we probably can get it covered somehow.
I think we'll bring it up. Let's do a little more homework, and I'll send them an email just to beg, and then we'll bring this up when we're meeting next month. This month.
And maybe one other things, we can actually have a look at the regression test that we have now, and if there are like some redundancies. Well, I'll take care of mine. I think I can remove a couple of one so that I can save some time already.
Yeah, maybe if you can go through your cases and see where you can maybe save some time.
I think everybody can do that, and we can save some time overall. Though it's a small percentage.
But reducing the number of regression tests is probably not a good idea, right? You want to test as much as possible.
No, but I mean, test that they test the same thing. I mean, like that you can, I don't know, maybe there is some feature that you can integrate in a single test case. That's what I mean. And then you don't have like two test case for, if it's possible. I'm not saying to remove crucial things, but rather if there is, we have this problem, maybe remove where there are redundancies, and maybe put some other tests like the SU2 Sol or other routines that are also important. And after the merge, we found always errors or
cursor mesh, right? So
all substitute with cursor mesh.
Yes.
Though I guess is the bottleneck, as Edwin said, is the compilation time, because I think it takes like 70% of the time, but that we cannot reduce.
Yeah. Okay.
One last thing on this, guys. So I think we have a plan. I'll write them and we'll bring it up at the meeting and we'll do a little homework. But maybe it's a good point to mention on the regression tests, should we standardize essentially the number of iterations and the tolerance? Is that something that makes sense?
It depends a lot on what you are testing. So I think it's very difficult to standardize.
Okay. Yeah, I'm just open to discussion on that.
Because, for example, I actually had to, whenever I have like outer loop, so I recently added a regression test for the adjoint FSI, and yeah, the number of iteration is not really a good parameter, because at the end of the day, because I have iterations in the structural adjoint, the fluid adjoint, etc. It was a bit difficult to set up, so it's fairly difficult to generalize number of iterations.
But I think at the moment this is a very particular case, while for all the other test case that are only flow solver, adjoint, and direct solver, I think a standardization can be done.
Yeah, possibly. I always have these cases, so for me they are the daily thing, so that's why I.
No, I agree. In fact, that for you maybe it's more complicated, but for the rest, maybe at the moment we can find, I don't know, we can decide to have 10 iteration and certain tolerance, and then before, and then we also have to decide when we are allowed to change the residuals. Kind of standardize a procedure when I'm allowed to change the residuals.
Oh yeah, no, standardize the procedure. Yeah, I agree. I meant more like in setting like a constant guideline is difficult, but definitely standardize the procedure is important.
Okay.
Okay, guys, I think we should move on to the Medi stuff, but just one comment on this slide. Compiler warnings. I mean, everybody, I think, should compile with -W all and -W extra when you're working on your machine, and fix any warnings as you go. I mean, this is just another one of these things that we all have to be better about.
Yeah, maybe if you do code review, also have a look at Travis and look at the output of Travis. I mean, you see there are also a lot of compiler warnings already, and maybe remind the people then that they should fix it.
Yeah, good point. Maybe we can move to the Medipack stuff, and then if we have time, come back to some of these other issues.
Okay, so but just to summarize, so we agree on splitting the test in test cases and regression tests, because this should be maybe done before we deal with something else in the test.
Oh, you mean moving the tutorial, like the files that are for just the tutorials inside? Exactly. Sure, I mean, we can put it to a...
because then we can reduce the mesh sizes, maybe. Because then we are not limited by any... to stick to some physical solution.
Sure.
Okay.
Yeah, anybody disagree with that plan?
Okay.
Sounds
good. I can do that. Yeah.
Ready?
Okay, perfect. Then let's go back to
yeah, and by the way, I'll take the lead on I'll email Travis and all that stuff. So
okay,
go ahead.
Perfect. Yeah, should we start? Yeah, we just start with the first one, I would say here. So there were suggestions to implement a pressure-based incompressible solver. I, for myself, I'm not an expert on this kind of solvers, so I don't know what the performance is, what the advantages are compared to the density-based one. So yeah, so this is just these are just my opinions here. That it is complicated to maintain both, I think, and I don't know if it is really necessary to have both. This is just my opinion, my questions.
Yeah, I think Edwin, maybe you can comment here on what you guys are up to.
Oh, maybe he's not here.
But maybe we lost him. Yeah, so just to comment here, because we'll make this quick, because I really did want to spend some time on any stuff. But yeah, so at Bosch, we're working a lot with the current density-based solver, the artificial compressibility, and we're putting in a lot of improvements there. And then Edwin has a student who is starting up who is looking at creating a pressure-based solver. So I understand that's being worked on and that's coming over the next year or two. I think having both would be great, but it's going to take some effort to get the pressure-based one completed.
We did experience some problems in like I had it there, like very low Reynolds flow. Like we were playing around with some Reynolds one test case, and the artificial compressibility did not even get any closer to convergence.
Yeah, the problem is at the moment you have to tweak the compressibility factor.
Yeah.
Oh no, I played around a lot with compressibility factor, but at some point, like we kept reducing the Reynolds, and at some point it didn't even.
Guys, I'm well aware of the problems. I've been spending a lot of time the past couple of months trying to get that improved. So we're working hard on that. And yeah, the beta factor is critical, and the way it scales in the mesh. So even mesh size and local Reynolds number, all these things are very important. So working on that, we'll hopefully have something. I'll be able to push something in the next month or two that is more robust. So.
That sounds great. Yeah.
Yeah.
So Tom, you said that Edwin is currently supervising a student that is implementing the pressure-based then.
Hello?
Yes, that is correct. So I think Akshay is joining the developers meeting. In fact, Edwin, are you there?
Yeah, sorry, I got a phone call, some personal matter. So, but I'm back again. Yeah.
Yep. We were just saying that Akshay, who's working with you, will be looking at the pressure-based solver. Yeah.
Yeah, that's correct. Yeah.
Okay. Yeah, we'll have a chance to chat with him, I guess, all about it and connect and discuss plans when he's here in a couple weeks.
Yeah, as a matter of fact, he's probably joining this meeting as well, looking at this meeting as well, because I saw him today still.
Oh, great. Okay.
Hello.
Hello.
Hi, is that you?
Hi. This is Akshay speaking.
Hey, great.
I was just listening in. Yeah, I'm just working on the Poisson solver for now, and yeah, maybe we can discuss something in the next couple of weeks.
Okay.
Awesome. I mean, it would be cool to see some. Yeah, I mean, I still don't understand the difference. Also, not the difference between the solvers, but the disadvantages and the advantages. This is always my problem.
The unsteady solutions actually, because right now with the artificial, we are not able to get any accurate unsteady problems. Like at the company I work, we work mainly with the stick trailing edge airfoils and so on. So we have like a lot of separation issues. And these are very low Mach number, but high Reynolds number, and we have a lot of separation. With the artificial compressibility, like we have to go like really small mesh sizes, and we have like a lot of computation time. And we feel like with this pressure-based, maybe we can improve some performance in that.
One question that is also another slide. Are you guys planning to develop the pressure base and to incorporate ALE formulation for it?
Moving grids.
Yeah, that's the intention. At the end, it's not the first priority, but we'll have to. We will later on the list. Yeah, because it's wind turbine application, so then it's moving blades.
All right, that sounds great. Thanks, everyone.
Yeah, I can say that for the existing density-based one, there's also interest at Bosch in having some grid motion capability. So yeah, same thing, not the highest priority, but it's coming.
It should be quite easy, right? This is, as far as I understand it, to incorporate it in the current one.
Yeah, it'll look just like the compressible for the most part. I mean, we reuse a lot of the same time marching and all the same solver structures.
I think it is just missing in the numeric structure.
Numerics and the time stepping and stuff like that. Well, it's because we copy pasted from the compressible. A lot of it's there, but it needs to all be double checked. Yeah. But yeah.
Yeah. Okay. Yeah, but we should keep that in mind that I don't think that it is a problem of the artificial compressibility method itself, that it performs maybe not the best way at the moment. It's just,
I think it's all about performance. I mean, at convergence, I think it also depends on the type of problem you're interested in. Yeah. So if it's steady, I think artificial compressibility is very good. Unsteady, it could be fine. A lot of people do it, but yeah, we'll just. I mean, I think having both solvers and comparing would be great.
Indeed, of course. Oh. Okay. Yeah. So this is this is about Medibag.
Yeah.
So I opened this pull request this week that essentially gets rid of edge on MPI to differentiate the MPI communication. And along with that, I also changed some other stuff related to the MPI things. So we have this MPI wrapper, and I cleaned it up a little bit. And I added also more functions. So almost all of the MPI calls are now replaced with this wrapper call. That should also make it easier, for example, to get rid of the if-def stuff for the case when you don't have MPI. And I also removed all this get rank and get size stuff that was in there. Yeah, and I think that's better to have more routines for the differentiation in the end. Yeah? So we cover more edge on MPI calls. The goal is at the end to cover everything, but I don't think that is possible. But we are at 85% or something like that from the standard. So yeah, that's the status on that.
So yeah, this is very important. It affects a lot of stuff. So I think Edwin's already chimed in on the pull request itself, but I mean, are there any lingering issues with what MPI functions we can use now, or are there any other ones in branches that we need to include that aren't yet?
So if someone needs a special function, I can have a look at it, yeah. For example, it's one routine that that Edwin suggested. Unfortunately, that's missing at the moment.
Which one is that?
I don't know. You wrote this list there on the.
Yeah, I have an all get a V in there. Reduce scatter, I think.
I think that one second. I can.
Probe.
No, probe is working. The reduce scatter.
Yeah.
This is, I think, the one that is missing at the moment. Yeah.
Okay. Well, it would be nice to have because reduce scatter, but it's been used only with integer arguments, so it's not strictly necessary. But it would be nice to have all MPI, in my opinion at least, I don't know what you think of it, to have all MPI routines wrapped such that you don't, some of them are not wrapped and other ones are wrapped. That's a little bit messy. But
exactly. Yeah. Yeah. I mean, it is of course a little bit complicated to add all the routines that MPI offers.
Yeah, I can imagine.
But yeah, I think also maybe it's also included in Medipec, but it's maybe not differentiated or something like that. That might be the case, actually. But we can definitely add it to the wrapper and throw an error, for example, if you call it with an MPI double.
Yeah, that would be nice. Because at the moment I only have it. I only use it in common with integers.
Yeah. Oh, that shouldn't be a problem, I think. Can definitely do that. Yeah. But we cover definitely much more now, and it's also better for the future. So we hope that we can also have during the next year higher order derivatives in Medipack, and then yeah, that maybe is also interesting for some people.
Yeah, the reason I was stressing it so much is this is sort of yeah, I guess a prerequisite to merging in Edwin's work with the high order solver into develop, which we would like to do pretty soon. So it's becoming very cumbersome for Edwin to kind of stay up to date with develop because we're changing so much. And for now, over a year, 2 years? How long has it been, Edwin? You've been tracking the develop branch and merging changes, but it's been pretty difficult, right?
Yeah, it's 2 years. Well, yeah, it depends a little bit on the change, but sometimes there are conflicts, and then you have to add it manually, and I then have to spend a day or so resolving the conflicts, and I could think of a better way of spending my time.
Yeah. So I think we want to get this. So I guess I'm just highlighting that a lot depends on it, and it'd be good to get all the different MPI functions put in so we can get Edwin stuff into develop, even if it's not released officially yet, just to make his life.
And in case some routing is missing, it's just very easy to add it to the wrapper. Yeah, that's essentially a no-brainer, I would say, if something is missing.
Yeah. What about? I don't know if you already did it, but MPI barrier and all these functions, did you add it too?
Yeah, I replaced also these routines.
Okay.
Yeah.
Okay, good.
The only thing that is not replaced is, for example, the communicator and the MPI double. So the macros are not. Yeah. I don't know if we really want to do that because this might confuse people. But let's see.
Yeah, and the buffer detach and all that, you removed that, right?
Unfortunately, not yet, because I saw that it's still used somewhere, this bsend in the code.
Okay.
Oh, is that in the near field?
Somewhere I saw a bsend. This is why I've not removed it yet.
Yeah, we might be able to take that out. I don't know if Francisco's here, but there are one or two places where we did it a long time ago. But
I'm here. Yeah, I think we can. Yeah, we can remove that. I don't think we're using it.
Or something. It should be possible, I guess.
Yeah, perhaps we could remove that. Maybe we can talk about it on the pull request in the code review. We can just highlight that. I think it might be out of date. I don't know that we're using it.
No, I don't think so. I have a comment with respect to the MPI. It's very basic, but probably you have noticed that if you run with MPI, you don't have an error messages when, for example, the config file is wrong. So that happens to me a lot of time, that the output is not done, so you don't see what is happening, and you need to run it in serial to identify the problem. So I think we need to fix that.
Yeah, it's good that you bring up that point, because also Tom replied on that topic, I think, in this pull request, and in fact I implemented a consistent way of throwing an error in parallel and in serial. And I also replaced all of the messages that I saw already. And yeah, I mean, you can have a look at the pull request. There I also have an example how it looks like at the moment. And yeah, if you don't like it, then just tell me. It's just a proposal. But you just call SU2 MPI error, and then you give it a string, and then the current function, where this is a macro that simply expands on compile time to the routine name. I think it's simple, but you get a lot of information out of it, I think.
Okay, that's great. I have only 5 minutes. Can I say something? Maybe you have discussed this topic before, but just in case. Have we spoke about the CFD online forum? Because we have now a lot of developers, and I think the CFD online forum is critical for the success of SU2. So if we have a commitment of looking at the forum and trying to replay questions from the open source community, I think that could be very important for the success of the initiative. I don't know what are your thoughts on that, but yeah, there is a critical mass of developers who understand this software very well, and they can replay a lot of questions, and it's the way to grow, I think. I don't know what it's just because I have a meeting right now, and I would like just to.
Yeah, I mean, there are a lot of people in the forum. A lot of people are asking.
There are a lot of people in the forum, but qualified replays there are not so many. I think we have a lot of developers that if on weekly basis they take a look at the forum and replay something with a complete answer.
Yeah.
Then that will increase a lot the forum, and it's what people see. I think it's very important. I don't know if there is any commitment to work on that. That would be great, or reminders, or we can send to the developers, user, an email every 2 weeks. Just reminding, have you looked at the forum? Do you want to contribute to the CFD online forum? I think that would be useful.
That's
we typically
idea.
forget about that. Yeah, I think we don't need to saturate people with emails, but reminders are useful if they are used carefully. So, yeah, I would vote for just an email every 2 weeks. So, just saying, why don't you take a look at the forum and then you replace them?
Yeah, it's a good idea. So, comments on that? Okay. So,
yeah, so I agree with that. I think it's great. It goes, in my mind, similar to documentation and answering issues and stuff like that. I mean, we all have to chip in. So yeah, please do.
Also for the pull requests, right? I mean, everybody's invited to look at the pull requests, huh? So
yes,
that's
yeah. Maybe it's important to point that out.
Running out of time, but then we should clearly state what should go on the issues on GitHub and what on the SU2 forum. But that's something else.
Yeah, there's not a clear distinction between this. I think it's hard to.
Yeah.
Yeah, I think the general philosophy is if it's more of a user question, it should be on the forum. If it's more of a code/developer thing, an issue, then it should be on GitHub. So every now and then, if a user question shows up in the issues, we can close it and point them to the forum, and I think that's okay.
Mm-hmm. Okay, all right. Yeah.
But if it's a user reporting a bug,
yeah, then not. Then it
has to go an issue, right?
Yeah, sure. If it relates to code changes, then I think it belongs on GitHub.
Okay. No, so okay, it's clear.
Perfect.
Okay, so something in particular you want to talk about in the last 4 minutes?
Well, so was everything finished with the Medipack stuff, Tim? I mean, do you need any help with final reviews, or what do you need to get that integrated?
Yeah, I mean, I can only encourage people to have a look at it and tell me what they think, whether it's okay this way, the error messages, for example. Yeah. That would be quite helpful, I would say. Yeah.
Okay.
Whether you agree on that or not.
Okay. Yeah, I'll take a look at that. I really like what you've added, so I mean, you already kind of know my opinion, so other people can chime in.
Yeah.
Same thing with Ruben's pull request. I don't know. Has that been reviewed? Yeah, as of today, I think as of yesterday it hadn't. So.
Yeah, actually, we yesterday, me and the team, we went over it. So
okay.
we just got it merged today.
Okay, so maybe that happened overnight for me.
It happened overnight for you. So basically, yesterday me and team went over the different files in the pull request, etc.
And there will be some follow-up pull requests. So.
Yeah, there's another pull request because I'm putting together now like the tutorials, and as I go along writing the tutorials, of course there are options that I think are more clear to have in different ways, or options that I have been adding, etc. So I will have another pull request hopefully by the end of the year.
I have a last comment. I really like this meeting. I think it has been great. So my suggestion is that maybe we need to have another one for the next release. So traditionally, the releases have been done by the developers team, isn't it, Tom? So the next release is going to be awesome. There are new capabilities, probably the best release that we have ever. So we need a 1 hour meeting to decide how we are going to distribute the work, and especially how we are going to communicate that SU2 is there and is, I think, much better than most of the commercial software that you can find. But that's a communication strategy that we need to develop. And it's very important. Otherwise, the initiative is not going to grow. We want this to grow. So team, if you can organize a 1 hour meeting to chat about just how to distribute the work for the...
What do you think is the time frame? So when you think?
This time frame works for me even at 7 here, Pacific time is okay. 8 is perfect, obviously. So maybe next week before the holidays, I think could be useful. But anytime will work at the end. So.
Okay, so as soon as possible.
I think so. I think we should target really the AI AA conference for the release. That worked great, and I think it's a good place, isn't it, Tom? What do you think?
Yeah, we've always tried to line it up with the conferences because it's just good marketing. I mean, we send a big email. A lot of people at the conferences presenting papers. It gets a lot of buzz, so it's been a good strategy.
Sorry, I have a meeting right now, but thank you very much for organizing. It has been great. Thank you.
Yeah.
Bye.
Bye.
Okay. Bye. Yeah, I mean, we are more or less finished, I would say. I promise to cut it at 7.
Yeah.
Yeah, but I think we should have this more frequently. I don't know what your opinion is.
I agree. I think at least every quarter, maybe more regularly.
Yeah, I think it's useful too. By the way, I have to run as well, but it was indeed just very useful, I think.
Okay.
Okay.
Yeah, thanks for staying, gentlemen. Later.
See you guys.
Bye.
Bye.
Okay. Yeah. Then I will maybe set up a next one at some point.
Yeah, I think to finish Francisco's point about the release stuff, there's a lot of there's not a ton to do. Well, okay, that's a lie. There's a bit to do. We have a lot of scripts that automate stuff. So I have scripts that kind of create the releases, create the binaries. We do emails and all that kind of stuff. So yeah, if we could share that load, that'd be great. I think that's what he was trying to say. And then there's also preparing code stuff, checking for bugs, final pull requests, all that. That we need to have a focused goal to get that all together.
It would be great if some of the people could help with that.
Mm-hmm.
I will set up a meeting for this matter. And yeah, everybody's of course invited.
Okay. And then maybe a final summary, just a rundown of what I wrote down. So Salvo, I think you're going to take a look at the output.
Yeah, I will.
From Ruben. And then I can take care of the periodic stuff and the partitioning stuff. Ruben, you're going to take a look at adding maybe an index at the highest level, so separating geometric zones and physical zones and that kind of a thing.
Yeah, I'm going to look into like what I think was Francisco who suggested that we could just come up with like the most difficult problem and
Exactly.
Yeah, I agree. Yeah, I'll get that.
Ruben, were you also going to look at the split communicator idea? I don't have anybody written down for that. So how we send cores basically either to the flow problem or structure problem or whatever. Does anybody want to look at that? Maybe you already have something on your plate.
I could look into that, but I think possibly like if a team is working into the new
maybe we can say that.
Maybe we can if you help me out with that will be great. Yeah,
of course.
But maybe also Edwin is the more expert on this.
Yeah, possibly.
Yeah, we could ask some help from Edwin. Okay, so then regression stuff, I had written down that Tim, you'll take the lead on separating out the tutorials from the regular ones. I'll go ahead and write Travis, and I'll make sure it gets brought up at the developers meeting if we just need to buy it. We'll just beg the folks there. Okay, forum and email and next meeting stuff. Okay, I think that's all I had written down. Anybody else have any final stuff?
Not at the moment. I think that's it for now, I would say.
Yeah, it was a very good meeting, I would say. Yeah, we should have started to do this maybe also some times ago, so that more. But it's good. Better later than never.
Yeah, and I hope we can get all these things started. I mean, the output structure really waits.
Yeah.
We discussed that a long time ago.
Yeah, maybe Ruben, I will also contact you because you said that you recently had some to do with that, and maybe your situation is also the more critical to handle also for the output point of view. So I will certainly contact you.
Yeah, just contact me, and I can tell you.
Yeah, okay. I mean, I'm also happy to help with some of the things. It's not the problem, of course.
Sure. Yeah. I mean, I think everybody should help out. Just, let's have somebody leading it. Just if nobody's pushing, then, things don't happen. So let's make sure at least one person is kind of responsible.
Yeah, this is a good idea, I think, to just name some persons.
Yeah, I mean, and they can go ahead and ask people for help. That's no problem.
Yeah, that's cool.
Yeah, I would like to help on the physics, on the indexing on the physics. So Ruben, if you have any, if you need any help, you can contact me on this test case you want to set up.
Cool. That's great. Yeah, thanks, Ruben.
Great. Tim, not to add more work for you since you're the one who organized this, but perhaps if you have a minute, could you just separate out the topics we didn't get to from these slides and put them on a new slide and just save, for next time?
Yeah, I will do that.
Okay.
Yeah.
Okay.
Yeah, and then, so then this is on YouTube, yeah? Is that...
Unfortunately, in between, the stream broke down a couple of times because it's not very stable for Jitsi to YouTube. Okay. Yeah, but most of the things are recorded, and it's online. Will be online as a video. I will have a look at it and how it.
Were the slides?
No.
There?
The problem is I cannot choose what should be streamed, so the slides are unfortunately not streamed.
Oh.
But so what was streamed?
Just the Jitsi
interface.
Yeah.
Okay,
but I sent a link with the slides on YouTube and on the description. So
yeah, perhaps we can contact also the guys of Jitsi and ask for some support, since it needs some improvement.
It's a nice feature, but unfortunately, it's not very stable. I had to try it 50 times until it started. So.
Okay, maybe next time we can try to stream with sharing the screen, or if it's possible, we can try that.
I don't have an option to choose this, but maybe we find a way to do that. And we should continue it like that. I think it's good to have it also as a recording, because then we don't need to take detailed notes.
Yeah, indeed.
Yeah. Okay. Then, thank you. And until next time, or maybe until 18th of December.
Yeah, exactly.
For who is going, guys? Unfortunately, not everybody can join, but we will certainly be on the phone.
That's at least something.
Enjoy, guys.
Get you guys there. We'll send out I've been working on the agenda the past couple of days, so we'll send that out very soon.
Okay,
and then, yeah, please register. I think most of you guys already did, but that way we can email you with the virtual meeting stuff when it's ready.
Cool.
Okay, and I will set up a meeting for next week for the people who want to get involved with the release.
Okay. All right, guys. I gotta run. So
no problem. I think we can stop it right here. And
yeah, I think we can put it.
Bye.
okay.
Yeah, go ahead. Friday night. Enjoy.
Yeah, have a good weekend. Bye.
Bye.
Bye-bye.
Okay, bye guys.